day, ladies and gentlemen, and welcome to the 6-month progress report of the first-year students of Translational Medicine Center. My name is Dénes Kovács, and let's have a little chat about human papillomavirus infection. So I'm a resident at the Obstetrics and Gynecology department of a university, and my mission is to emphasize the importance of prevention and to help improve reproduction rates as well. And I hold my mission sacred in my work, which is that all people should be able to create a healthy family. Let me introduce you my specific goals. The first project that we are currently working on has started in last year, September, and it is about human papillomavirus infection and adverse pregnancy outcomes. The second project is about investigating cancer prevalence among human papillomavirus vaccinated patients, and we have just started this project this March. So let's have a closer look of my first topic, with which I'm very happy to have some great colleagues on board. Human papillomavirus infection has got into spotlight lately because of German virologist Harald Zurhausen, who actually discovered its connection to cervical cancer. And we also know that human papillomavirus infection is one of the most widespread and common sexually transmitted infection worldwide, with a live prevalence of about 80%. We also know that in vitro studies have proven that HPV can actually inhibit blastocyst formation and endometrial implantation, or can cause apoptosis in embryonic cells as well. And from observational studies, we also know that it is associated with preterm delivery, premature rupture of membranes, or pregnancy loss, among other pathological entities as well. We also know this, but the results are quite conflicting, and therefore we aimed to assess the prevalence of pregnancy outcomes in human papillomavirus infected population. So our clinical question is that are adverse pregnancy outcomes more common in patients who are exposed, or rather infected, with human papillomavirus infection? And we have compared this population with the not infected population. And our outcomes, of course, are the before mentioned outcomes, such as preterm delivery or premature rupture of membranes. Our hypothesis is that these adverse pregnancy outcomes are actually more common, and HPV can actually lead to these pathological entities. The clinical implication of this study would be to emphasize the importance of prevention. We have carried out a systematic search on the 10th of November last year in 3 major databases with the following search key that is made out of 2 major domains. The first one is about HPV, or rather human papillomavirus, and then the second one is made of all the pathological entities that we were looking for as an outcome. This is my flowchart of selection, and all in all, our search key yielded 7,070 articles, from which, after duplicate removal and title and abstract selection and full text selection, we have managed to find 22 fully eligible articles that we have included in our study. And our outcome measure was a confidence interval with a 95%. We have actually finished analysis with the crude odds ratios, but we are still waiting for the adjusted odds ratios, and we are hoping to receive these values by the end of this month. So, let me introduce you my first forest plot, which is about preterm delivery among infected and not infected population. And preterm delivery is about, the prevalence of preterm delivery is about 8% here in Hungary today, which is almost the double of what Western European countries claim, and this is a major problem. So, our effect measure was odds ratio, and the effect size was 1.62, which is definitely clinically relevant and statistically significant as well. This is my second forest plot about premature rupture of membranes. As you can see, our outcome, the pooled odds ratio was 1.30, which is definitely clinically relevant, but statistically rather insignificant. My third outcome is about low birth weight. As you can see, human papillomavirus infection is not actually associated with low birth, and also with spontaneous abortion as well. Yes. So, The strengths and limitations of this study. The strengths are that this study that we have carried out is actually quite comprehensive and has a large sample size as well, with a huge population of more than 400,000 patients. We have included a rigorous inclusion and exclusion criteria that the previous meta-analyses have not carried out. But the limitations is that there are various strains of HPV, and this can cause a high heterogeneity throughout all the studies, and it is very difficult to assess. Which actually is my second point as well, the high heterogeneity, and also the confounding factors are also not very well defined as well. So what is the conclusion? The conclusion is that HPV infection is visibly associated with preterm delivery, but otherwise not associated with premature rupture of membranes, preterm premature rupture of membranes, spontaneous abortion, or low birth weight. The implication for the practice would be to have more frequent testing and also to test pregnant patients as well. And maybe it should be obligate to get vaccination before family planning as well. Implication for research is that a better vaccine is needed for more strains, and also treatment alternative would be sufficient to find. And also future studies should be carried out in this topic to assess the effect of vaccination on pregnancy outcomes as well. So this is the manuscript status currently. Actually, we have almost finished all the steps of it. We are just doing the fine-tuning, rather. We have a bunch of selected journals as well, target journals, but the number one is reproductive biology and endocrinology, and we are hoping to send them the manuscript very soon. So let's have a closer look about my second topic, which is about investigating the effect of human papillomavirus vaccine on cancer prevalence. We know that HPV is already linked to oropharyngeal, anal, and genital cancers, and also linked to or associated with different cancer types as well, such as lung cancer. But we would like to assess the prevalence of different cancer types among HPV vaccinated women, and we are hoping to do this by register analysis. Our clinical question is that, does HPV vaccination decrease the prevalence of yet unlinked cancer types in general population, women rather? And we would like to compare the vaccinated and the not vaccinated population. And the outcome would be, of course, the different cancer types as well. Our hypothesis is that HPV vaccinated population is somewhat protected from different cancer types. And the clinical implication would be to have more vaccination and decrease the number of cancer prevalence. So these were my two topics, and thank you for your attention. And let me introduce you the saying of Miyamoto Musashi, which is that if you know the way broadly, you will see it in everything. Thank you.
Thank you for your presentation. I would like to ask about the second topic. If you're going to, what time amount are you going to consider for the analysis of this prevalence? So if they got vaccinated, after how many years of this vaccination they are going to be affected by cancer or not? So what is your time spent for this? Okay, so in the countries where they have good registers, for example Australia or the USA, they have started the nationwide vaccination programs in 2006 or 2007, and the registries have also started from there. So that's day one, and they're still going on. And so we would like to assess cancer types that are more frequent among young population. So the time span altogether is somewhat 15 years or so. And also, these patients received the first vaccination when they are somewhat 12 or 13 years of age. Did I answer your question? Thank you.
I hope so. Thank you for your question.
My question would be regarding your first project and regarding heterogeneity. Can you explain us what happened with the Nimrod study?
Yes, of course. Let's go back.
It seems.
Which outcome?
For the first.
Is it this one?
Yes.
Okay, so one of the major causes of heterogeneity in this forest plot is that these study designs are actually different, because there are some observational cohort studies, there are cross-sectional studies, and there are case control studies included as well. Well, of course, the population selection can be one major problem of it, because the case control studies, it can actually very differ quietly. And the ethnical and geographical background is also a factor here. Another huge cause of high heterogeneity is that the different mode of diagnosis of HPV infection, because a bunch of these studies diagnosed HPV infection from placenta with a PCR methodology, and then different study types diagnosed HPV infection by a pap smear and HPV genotyping. So the site of sample taking was different, and also the mode of diagnosis, the mode of well, the laboratory techniques were different as well. And that is the reason why you can see that the forest plot is actually going from up to down, from left to the right, and actually quite heterogeneous.
Congratulations for your presentation. I would like to ask a question about your first project. So about the inclusion and exclusion criteria. So did you included or excluded patients with systemic diseases, for example, diabetes?
With what?
With systemic diseases, for example, diabetes, or how did you deal with smoking, maybe?
A number of the studies had adjusted values as well. Unfortunately, not all the studies, but those ones which had adjusted values, they have adjusted for a lot of confounding factors, such as maternal age, number of gestational, the number of parity, actually, and smoking status, and also family background as well. So altogether, all my articles were made out of patients who were actually women of fertile age and otherwise healthy. I've excluded all the patients who were, for example, HIV infected or had any other major illnesses. Yeah. Thank you for the question.